Hi, in this video series, we're going to talk about BIM, digitalization of construction, and ISO 19650. We're going to try to move from the simple to the complex. And we're going to start talking about the evolution of information representation in construction. BIM is now called a new paradigm in the presentation of information in construction. To understand why presenting information as a BIM model is recognized as a paradigm shift, it is important to do the following. First is to trace the various stages in the evolution of forms and ways of presenting information about a building, and second, to identify the key preconditions and problems of transition between each stage of evolution. Five basic stages can be distinguished. Let us briefly discuss each of them. Stages of methods of presenting information about a building. 1. Mental representation of a building. 2. Representation of structure information in the form of drawings. 3. Digital representation, first CAD. 4. Representation of information by means of object-oriented 3D CAD. 5. Representation of information about an object in the form of a BIM model. Let's talk about each stage. So, first stage. Mental representation of a building. Ever since civilizations began to build structures that required more than one person, people have tried to mentally imagine the structures they were going to build and share their ideas with others. It began with simple oral descriptions and rudimentary sketches in the sand and evolved into drawings on various forms of papyrus, parchment, stone, and paper. Some of the earliest drawings can be found in Marcus Vitruvius' treatise 10 Books on Architecture. Communicating mental models of building structures with something more than speech essentially began with the advent of Euclidean geometry some 2,300 years ago and did not improve much until the invention of descriptive geometry in the second half of the 18th century. Euclid's work was the first rules of representation based on the axioms used by architects of the time. Second stage. Presentation of information about the structure in the form of drawings. The second and longest stage in the history of construction is the presentation of information about the structure in the form of drawings. There is always more than one or two people involved in the construction process, and there is a need to develop a unified, clear and understandable to all view of the future construction. Thus began the era of drawings as the primary method of presenting information about a structure. At the beginning, drawings were drawings made according to simple rules. In the modern understanding, such drawings can rather be referred to sketches and schemes. However, there were disadvantages to the presentation of information in the form of drawings. 1. High labor intensity of developing drawings and making changes to them. 2. Many routine operations and, as a consequence, the need to maintain a large staff. 3. Considerable time to coordinate changes with other participants. 4. Construction according to blueprints has always been fraught with the risk of collisions at the construction site. 5. Is still the absence, as a rule, spatial representation of the structure, physical models. 6. Reading blueprints is not available to everyone. There is always the risk that the customer may not be satisfied with the result of construction. Third stage. Digital representation, first CAD. To the third stage we refer to the period when architects and engineers began to use CAD. The first digital methods of presenting information were aimed primarily at increasing the productivity of creating drawings. The only difference was that now, instead of using ink and paper, architects and engineers could create the same 2D views using a computer. Although CAD had many advantages, such as automating the rough tasks of drawing repetitive parts, automatic accurate dimensioning, electronic storage and file transfer, in concept CAD was no different from drawing on paper. Fourth stage. Representation of information by means of object-oriented 3D CAD. The so-called object-oriented 3D CAD has become a bridge between modern information modeling and CAD. Electronic file formats, originally designed to store only graphical information, with the advent of object-oriented 3D CAD can now transmit information about the structure that is not directly displayed in the drawing. The objects of the data in these systems were the structural elements of the structure, such as doors, walls, windows, roofs, supports, and foundations. These elements were also capable of storing non-graphic data about the structure in a logical structure along with graphical elements. 3D CAD systems, by definition, supported the creation of design solutions in the form of spatial objects. Such systems already had functions of creating drawings on the basis of pre-developed 3D models of structural elements. Thus, the use of CAD files has evolved in the direction of communicating information about a structure in ways that are not available for paper drawings. Fourth stage, representation of information about an object in the form of a BIM model. The era of object-oriented 3D CAD did not last long, and at the beginning of the 21st century the first systems appeared, at the development of which the task of automatization of drawing output was relegated to the background. There was a shift of goals, first of all, to the presentation of information in the form of structured data. Information modeling technology is the result of the convergence of several digital technologies, object-oriented representation of information. Unlike 3D CAD, each object in a BIM model now knows what it is as a structural element. Storage of information not in files, but as a database. Use of the internet and cloud technologies for collaborative work in a shared data environment. The use of open formats for storing and sharing information. Creating and using a digital prototype of a future structure. In this video, we briefly looked at the evolution of the presentation of information about a construction. In future videos we will gradually approach more in-depth topics including Industry 4.0 and ISO 19650. For now, thank you for watching, like and repost, and see you soon.